Fossils are the remains of ancient life. They are like clues that tell us about plants and animals that lived millions of years ago. Some fossils are bones, teeth or shells. Others are footprints or even burrows left behind by animals. Paleontology is the study of fossils. Scientists who study fossils are called paleontologists. They are like detectives who use fossils to piece together Earth's history. By studying fossils, we can learn about creatures that are now extinct, meaning they no longer exist. Fossils are found all over the world in rocks of all ages. Some fossils are tiny, like the shells of microscopic creatures. Others are huge, like the skeletons of dinosaurs. Fossils give us a window into the past, allowing us to travel back in time and explore the amazing diversity of life that once existed on Earth. Fossil formation is a rare event. Most dead plants and animals decompose quickly. For a fossil to form, the organism usually needs to be buried quickly after it dies. This often happens at the bottom of a lake or ocean. One way fossils form is through petrification. In this process, minerals in groundwater replace the original organic material of the organism. The result is a heavy, rock-like copy of the original organism. Another way fossils form is when an organism leaves an imprint in soft mud or sand. This imprint can harden into a mold. Later, minerals might fill the mold, creating a cast of the original organism. Think of it like making a jello mold. The mold is the imprint and the jello is the cast. There are different types of fossils, each providing unique insights into the past. Body fossils are the preserved remains of an organism's body parts like bones, teeth and shells. These fossils tell us about the size, shape and diet of ancient creatures. Trace fossils are not actual body parts, but evidence of an organism's activity. These include footprints, burrows, and even fossilized dung, known as coprolites. Trace fossils help us understand how extinct animals moved and behaved. Microfossils are tiny fossils that can only be seen with a microscope. These include the remains of bacteria, pollen, and plankton. Those small microfossils play a big role in helping us understand past environments and climates. Section 4. Unraveling Earth's story, the importance of fossils. Fossils are incredibly important for understanding the history of life on Earth. They provide evidence for evolution, showing how life has changed over millions of years. By comparing fossils from different time periods, scientists can trace the lineages of organisms and see how they have adapted to changing environments. Fossils also help us date rocks. Certain fossils are known to have existed only during specific periods. Finding these index fossils in a rock layer helps scientists determine the age of the rock. Fossils can also tell us about ancient environments. For example, finding fossils of marine animals in a desert suggests that the area was once underwater. By studying the types of fossils found in a particular location, scientists can reconstruct ancient ecosystems. Fossils also provide clues about mass extinctions, events where a large portion of life on Earth died out. For example, the discovery of dinosaur fossils alongside an impact crater provides evidence for the asteroid impact that led to their extinction. Section 5. Fossil superstars, famous discoveries. Some fossils are so well preserved or significant that they become world famous. Tyrannosaurus rex, the fearsome predator with its massive jaws and tiny arms, is perhaps the most iconic dinosaur ever discovered. Its fossils have been found in North America, providing insights into the reign of these apex predators during the late Cretaceous period. The woolly mammoth, a hairy relative of the elephant, roamed the frozen landscapes of the last ice age. Discoveries of frozen mammoths, with their fur and even stomach contents preserved, have provided incredible insights into their biology and the harsh conditions they endured. Archaeopteryx, a creature with feathers like a bird but teeth and a bony tail like a reptile, is considered a transitional fossil, showcasing the link between dinosaurs and birds. Its discovery was a major breakthrough in understanding the evolution of flight. Section 6. From fossils to fuel. Other uses of ancient life. Fossils are not only important for scientific research but also have practical uses in our daily lives. Fossil fuels such as coal, oil and natural gas are formed from the remains of ancient organisms that lived millions of years ago. These fuels provide us with energy for transportation, electricity generation and heating. Fossils also play a role in the construction industry. Limestone, a sedimentary rock often formed from the shells of marine organisms, is used in building materials, cement production and road construction. Fossils are also prized by collectors and displayed in museums, captivating our imaginations and inspiring a sense of wonder about the ancient world. The study of fossils contributes to our understanding of geology, biology and the interconnectedness of life on Earth. Section 7. Treasures of the Earth, protecting our fossil heritage. Fossils are irreplaceable pieces of our planet's history. Once a fossil is removed from its original location, valuable information about its context and surrounding environment is lost. It's important to protect fossil sites from damage and looting. Many countries have laws in place to protect important fossil discoveries. These laws might restrict collecting or require permits for excavation. It's crucial to respect these regulations and follow ethical practices when collecting fossils. By supporting museums and research institutions that study and preserve fossils, we can help ensure that these treasures of the past continue to inspire and educate future generations. The story of life on Earth is etched in stone, and it is our responsibility to protect and learn from this invaluable heritage.